Okay, so yes, this is a function. If you remember that the definition of a function is every value in the domain goes to exactly one value in the range. -7 goes to 8, 3 goes to 8, and 5 goes to 2. It doesn't matter that two of them go to the same value. Each of them goes to exactly one value. Is this a function?
No.
As it is written, it is not. Why is it not?
The 2 doesn't go anywhere?
The 2 currently doesn't go to anything. Now we could redefine the function to exclude 2 from the domain, and we would make it a function. That's one of the things we've looked at when we get with fractions, is we can restrict the domain to create a function. But as this is written, it is not a function as long as 2 is in that domain. How about this one? Is that a function?
No.
Why not?
8 goes to 2 values.
Yeah,
-8.
-8 goes to both 2 and -1. It goes to 2 different values. So no, that is not a function. We might have ordered pairs. Is that a function?
Yep.
It is, because 7, it's the first number that matters. It's the domain value. These are the domain values. And none of those values are repeated. So none of them go to more than one value. So yes, that is a function. Is this one a function?
No.
All right, this one is me not being very nice. It actually is a function. We see that 5 repeated, but in both cases, 5 goes to -1, doesn't it? So one of these is redundant. It's not necessary. So yes, that is a function if we as we exclude that redundant point. Is this a function? It is not. You are correct. And what makes it not a function?
The 2 goes to 2 numbers.
There you go. It is the 2 goes to 8, and then the 2 also goes to 1. So that is not a function. Is that graph a function?
Yep.
Yes. How did we test graphs to make sure they're functions?
Vertical line test.
Vertical line test. Perfect. And what that meant is we take a vertical line, pretend that's a line, and we move it across the graph. And if at any point that line crosses the graph itself more than once, it's not a function. Well, here, no matter where we slide that line, it only crosses the graph once. So that is a function. Is that a function? It is. It's not something we've talked about yet. So it's called a piecewise function. But if I take that line, it's only crossing the graph once. Still only crossing it once. When we get to here, that open dot at the end of that means that is not included in this portion of the function. The closed dot down here tells us that that is included in that portion. So as we slide across, that brown vertical line never crosses the function more than once at any given point. So yes, that is a function. Come on. There we go. How about that? Is that a function?
Oh,
No, it most definitely is not. Because anywhere along here to the other side of that vertex, a vertical line is going to cross it twice. That is not a function. Looking at equations. Is that a function? Do you remember what it takes to be a function? It must not have any powers on the y other than 1. That's true here. And the powers on x have to be whole numbers, 1, 2, 3, 4, 5. Can't be fractions, decimals, or we've got to be careful about negatives. That is a function. Is that a function? It is. Even though there are powers on x, those are all whole number powers on the x. So that is just fine. That is also a function. How about that? Y equals the square root of x plus 3 and then minus 2. Is that a function? No. Remember, the square root, that can be thought of as y equals x plus 3 to the power of 1/2. A square root is a power of 1/2. Then, of course, we got the minus 2 on the end. So that power of 1/2 makes it not a whole number power. So that is not a function. I mean, it would be similar to having a y squared, which also is not allowed. No powers on the y. We had mentioned last week that we could restrict the domain of this function, or restrict the range, I should say, to look like this. Y is equal to the positive square root of x plus 3, then minus 2. Then that would be a function, because then every value of x, there's only one possible value of y. But without that specifying that it's the positive square root, there are always two values for that square root, and that can't be true, can't be done. Given f of x equals 2x squared minus 7, g of x equals 3x plus 5, I want you to find for me f of 8, f of x minus 3, g of f of 4, f of g of 4, and g of x plus 9. I'll give you a minute or so to work on those. So f of 8 is simply going to be 8 put in where the x is. So 2 times 8 squared minus 7. So 2 times 64 minus 7, or 128 minus 7, which is 121. Any questions on that? F of x minus 3. 2 times, and in place of x, we put in x minus 3 squared minus 7. X minus 3 squared is x squared minus 6x plus 9. Oops, this is still a 2. We will multiply through that 2, distribute the 2. That's 2x squared minus 12x plus 18. We still have the minus 7 there. 2x squared minus 12x plus 11 is what we get. Any questions on that one? Okay, g of f of 4. That's saying we put 4 into f of x. F of 4 is just 2 times 4 squared minus 7, which is 2 times 16 minus 7, or 32 minus 7, which is 25. That's f of 4. So g of f of 4 is really g of 25. Well, g is 3x plus 5, so g of 25 is 3 times 25 plus 5. 3 times 25 is 75, plus 5 is 80. So g of f of 4 is 80. Any questions on that one? F of g of 4. That's saying we've got to find g of 4 first, which is 3 times 4 plus 5, which is just 3 times 4 is 12, plus 5 is 17. So now this becomes f of 17. So 2 times 17 squared minus 7. 17 squared is 289. 2 times 289 is, what, 578? Minus 7 is 571. Any questions on that one? Okay, and then finally, g of x plus 9. That's going to be 3 times x plus 9 plus 5. So 3 times x is 3x. 3 times 9 is 27. We still have to add the 5. G of x plus 9 is 3x plus 32. Now I want to take a look at this. We're going to forget that we saw g of x up above. If I tell you that this is g of x plus 9, and I want to know what is g of x, how do I get from g of x plus 9 back to just g of x?
Maybe just minus 9?
Okay, yeah, the relationship between x and x plus 9 is minus 9. So if I have, this is kind of sloppy notation, x equals x minus 9, if I subtract 9 from both sides, I'm dealing with x minus 9. So to get g of x here, I use the notation that I'm finding g of x minus 9 plus 9. If that makes any sense. What that means is I am putting x minus 9 into the function here for g of x plus 9. So this is going to be 3 times, instead of x, it's going to be x minus 9 plus 32. We'll go ahead and multiply that out. 3 times x is 3x. 3 times negative 9 is negative 27 plus 32. And we combine. G of x is equal to 3x. Negative 27 and 32 is plus 5. So in your notes, I want you to try this. I'm telling you that h of x minus 3 is equal to 5x squared minus 2x plus 3. Find h of x. I'm going to give you a minute to try that. So we're going to put in x plus 3 into this expression. So that's 5 times x plus 3 squared minus 2 times x plus 3 plus 3. X plus 3 squared is x squared plus 6x plus 9. Next, we're going to distribute the 5. 5 times x squared is 5x squared. 5 times 6x is 30x. 5 times 9 is 45. Also distribute the negative 2. Negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. And now we'll combine. We've got the 5x squared. 30x and negative 2x is 28x. 45 and negative 6 is 39, plus 3 is 42. h of x is 5x squared plus 28x plus 42. Any questions? So what if f of x is 7x minus 3 over 2x plus 4? I want you to find f of 3, f of x plus 2, and f of negative 2 for me. I'll give you a minute to find those. So if we take a peek here, f of 3, this is just going to be 7 times 3 minus 3 over 2 times 3 plus 4. 7 times 3 is 21 minus 3 is 18. 2 times 3 is 6 plus 4 is 10. That's 18 over 10, or 1 4/5. Or 1.8 would be fine. If you reduce it to 9 over 5, I would accept that as well. Any questions on that one? F of x plus 2 is a little trickier here. So that's 7 times x plus 2 minus 3 over 2 times x plus 2 plus 4. I'm going to work my way actually up here. 7 times x plus 2 is 7x plus 14 minus 3 is going to give us 7x plus 11 on top. On bottom, distribute the 2. We've got 2x plus 4 plus another 4 is 2x plus 8. So f of x plus 2 is 7x plus 11 over 2x plus 8. Any questions on that one? What'd you get for f of x or f of negative 2?
It's undefined.
Undefined. Why?
Well, because you get 0 on the denominator there.
Perfect. You get 0 in the denominator. When I put in negative 2 here, I have 7 times negative 2 minus 3, which is just fine. That's negative 14 minus 3 is negative 17. But on bottom, we have 2 times negative 2 plus 4. Well, that's negative 4 plus 4, which is 0. If we try to divide that out in our calculator, it doesn't work because that divides out to be 0. So we can't do that. So we cannot evaluate f of negative 2. It is undefined. And technically, if we go back to last week, the language we used for that is negative 2 is not in the domain. If we were to look at this original function here, f of x equals 7x minus 3 over 2x plus 4. Recall that there's two things we have to avoid. One is 0 denominators. And the other is square root of negatives. So if you recall, we have a function like m of x equals 7x squared minus 3 over 2x plus 14. There's no roots in here, so I don't have to worry about square roots. But I do have to worry about 0 denominators. So I take my denominator, 2x plus 14, and I set it equal to 0. And we just solve this like any other equation. Subtracting 14, 2x equals negative 14, and then
Divide by 2x can't be negative 7.
perfect. If we divide by 2, x is negative 7. That would make the denominator 0, so the domain of this function would be defined as all x such that x is not equal to negative 7. Remember this notation here? Our set notation? We used that when we were when solving inequalities a few weeks ago as well. So for this next function, find the domain of this function for me. P of x equals 93x plus x squared over 5x minus 3. I'll give you a minute or so, a half minute or so to find that. So we set that denominator, 5x minus 3 equal to 0, and we solve. Adding 3 gives us 5x equals 3, and dividing by 5. X is 3/5. So the domain of this function is all values of x such that x is not equal to 3/5. Any questions on that? Let's try one more. D of x is square root of 3x minus 8 over 2x minus 7. Define the domain of that function for me. I'll give you a little over a minute here. Actually, two pieces to consider on this one. Since there's a square root up there, 3x minus 8 has to be greater than or equal to 0. So we could add 8 to both sides. 3x is greater than or equal to 8. and divide by 3. Bless you. X is greater than or equal to 8/3 or 2 2/3. Then we also have the bottom here, 2x minus 7, which cannot equal 0. So we add 7, 2x equals 7, and divide by 2 to get x cannot equal 3 1/2. So putting this into set notation, it's all values for x such that x is greater than or equal to 2 2/3 and x is not equal to 3 1/2. Show of hands, how many of you had that? How many of you needed more time? All right, I'm going to give you one more example like that and let you try it. Let's see, q of x equals the square root of 2x minus 8 over 3x minus 6. I'll give you a minute or so to work on that. See what you come up with for the domain. So again, we have two requirements to meet here. The first is on top. 2x minus 8 has to be what?
Greater than or equal to 0.
Greater than or equal to 0. So we'll go ahead and add 8. 2x is greater than or equal to 8. And divide by 2. X is greater than or equal to 4. What's our other requirement? Three x minus 6 cannot equal 0. We usually write it as 3x minus 6 equals 0, and we solve it to find out what it can't be. So what are we going to do with that? Add 6. And then what? Divide by 3. So x cannot equal 2. So our domain here is all values of x such that x is greater than or equal to 4. Why did I not include anything for the x not equal to 2?
Well, because it's got to be greater than or equal to 4, and 2 is less than that.
Yeah, it would be redundant. This saying x is greater than or equal to 4, well, since this is smaller than 4, it wouldn't be part of it anyway. So we don't need to state that x can't equal 2 because it's already excluded with the x has to be greater than or equal to 4. There's something called interval notation. What interval notation does is it actually comes from the number line when we graph these. When we graphed something like x is greater than or equal to 4, we found 4 on the number line. And there was two types of dot we could use. We either used an open dot or a closed dot. Which type of dot is this going to be? Closed. It's closed because it's or equal to. So it includes the 4. And of course, greater than points to that arrow on the number line. So that's how that would be graphed on the number line. Well, there's other notation that can be used for this open dot and closed dot. An open dot is equivalent to a round bracket end like that. A closed dot is equivalent to a square bracket end like that. So sometimes when we graph those, instead of doing a closed dot like that, we might use a square bracket end. They mean exactly the same thing. The reason we would possibly use this notation over that is because it translates directly then into our interval notation. This up here is saying that x is greater than or equal to 4, as we've already stated. This down here is saying the same thing, but what it's saying is this. The possible values of x are between 4 and infinity. That thing that looks like an 8 tipped on its side is the symbol for infinity. If it's between 4 and infinity, that means x is greater than or equal to 4. Basically what we're doing is we're taking this statement here, rather than saying x is greater than or equal to 4, we're putting both a lower limit and an upper limit on x. Saying that x is greater or equal to 4 is saying that 4 is the lower limit. That's the smallest that x can be. Don't know why my x disappeared there. So that's saying 4 is the smallest x can be, and x can go up to infinity. So these two statements here, x is greater than or equal to 4, and 4 is less than or equal to x, which is less than infinity, say exactly the same thing. It is from this notation here that we create that interval. This is saying x is between 4 and infinity. This closed bracket is telling us that it's greater than or equal to. So if I have this range, x is, or negative 5 is less than x, which is less than or equal to 3. If I were going to put that on a number line, here's negative 5 and here's 3. Does it include the negative 5? No, it's strictly less than. That would be an open dot. Does it include the 3? Yes, that would be a closed dot. If I were using the other notation, this would be a curved end. That would be a square end. From that alternative notation, we get our interval. Negative 5 to 3, where the negative 5 is not inclusive and the 3 is. Not inclusive, that round bracket is telling us negative 5 is not in the interval. It's a limit, but it's not part of it. Inclusive, the square bracket is saying the interval goes up to 3 and it includes the 3. So if I wanted to use that interval notation to express the domain of a rational function like 5 over 3x minus 12, we know that 3x minus 12 cannot equal 0. We add 12, 3x cannot equal 12, divide by 3, x cannot equal 4. Well, that's simple enough to do in set notation. In our set notation, that's simply saying all values of x such that x is not equal to 4. If I want to express it in this interval notation, the first interval goes from negative infinity to 4, and then from 4 to positive infinity. Notice, well, you might be thinking, well, doesn't that include everything? Well, this round bracket on the end of each of those is telling us that that does not include the 4. A little side note, you'll notice that on infinity here, I used a round bracket, and up above, when it was infinity, I used a round bracket. Because, is there a difference between this and that? This is saying it goes up to infinity but never reaches it. This is saying it goes up to infinity and it includes infinity. Well, can we ever actually reach infinity? No. So this is technically incorrect to put a square bracket on infinity. Whenever there's an infinity, whether it's a negative infinity or a positive infinity, we use the round bracket on it because you can never quite reach infinity. So for this function, h of x, equals 7x minus 3 over 5x plus 25. I want you to give me the domain in interval notation. I'll give you a minute to work on that. So 5x plus 25 can't equal 0. Subtracting 25 gives us 5x cannot equal 25. Dividing by 5 gives us that x cannot equal 5. In interval notation, that is negative infinity to 5 and 5 to positive infinity with all the round brackets. A symbol that is used in set notation is an up.
Negative 5 up there.
Oh, you are correct. That should be a negative 5. So yes, negative infinity to negative 5 and then negative 5 to positive infinity. That's a negative 25 divided by 5 is negative 25. Thank you. The symbol that is often used for this, it's not an upside down U, I got that backwards. It's a right side up U, which stands for union. Union means or, either or. So if I have that written as negative infinity to negative 5 with a union symbol, negative 5 to positive infinity, it's saying it can be either or. The domain can be from negative infinity to negative 5, or it can be from negative 5 to positive infinity. Well, let's look at one more example with this. H of x equals square root of 2x minus 8 over 3x minus 12. Actually, let me make this 3x minus 15. Keep it interesting. I'm going to see what you guys can come up with in interval notation. See if you can come up with the interval notation for that. We'll go over it in, like I said, about a minute. So there's two qualifications here, two restrictions. 2x minus 8 has to be greater than or equal to 0. Adding 8, 2x is greater than or equal to 8. Divide by 2. X is greater than or equal to 4. So the reason I changed the bottom one is so that we didn't end up making it redundant. 3x minus 15 cannot equal 0. So if we add 15, 3x cannot equal 15. We divide by 3. X cannot equal 5. So these aren't redundant. Putting this in set notation might make it easier if we put it on a number line first. So here's 4. Greater than, 4. Greater than or equal to means it can be 4 or greater than, but cannot be 5. So what that means is we have to, at 5, we have to exclude the 5. That open dot there over the 5 will exclude the 5 from it. If we were to write that using intervals, the 4 is included. I want to erase this to get it out of the way. going up to the 5, but not including the 5, and then 5 up to infinity. So in interval notation, this would be 4 to 5 combined with 5 to infinity. Did anybody come up with that?
Close.
Close? Does it all make sense? Not sure yet? Okay. Getting from this, x has to be greater than 4 and x cannot equal 5. Getting from that into the intervals can be a little tricky. That's why I think about the number line of what can and can it not be on the number line. And I use that to create my intervals. Well, let's keep talking about the domains of functions. If I tell you that n of x is 7x over x squared minus 7x plus 10. Give me the domain of that and do it in interval notation. I give about 2 minutes to do this one. So here, the only restriction we have is x squared minus 7x plus 10 cannot equal 0. So we're going to solve it as though it does equal 0 to figure out what values would make it equal 0. So we're going to factor it. Because it's a quadratic, has both an x squared and an x in it, we can solve it by factoring. So x squared minus 7x plus 10 factors to become what? X minus 2 and x minus 5. So that gives us two equations. X minus 2 cannot be 0, or x minus 5 cannot be 0. And so we'll simply solve those by adding 2 here to get x equals 2. In other words, x cannot equal 2 here. Or adding 5 over here to get x cannot equal 5. So now the trick is putting that in interval notation. Well, it can be any value of x other than those. So it's going to start at negative infinity. The smaller one is 2, so it has to stop at 2. So we use that round bracket to exclude the 2. We're going to start at 2 on the other side again, still using the round bracket to exclude the 2. Then we'll go up to 5. Using the round bracket to exclude the 5, a union with, it can then go from that 5 up to a positive infinity. Again, using the round bracket to exclude the 5. Any questions there? We might have to try one more. G of x equals the square root of seven x plus 35 over x to the third minus 8x squared plus 15x. Want to see what you come up with there? I'm going to give you about 2 minutes for that one. So we have two restrictions. The first is that numerator. What's our restriction from the numerator? Perfect. Yeah, 7x plus 35 has to be greater than or equal to 0. So if we solve that, x has to be greater than or equal to negative 5. Good. From the denominator, we have the restriction. X to the third minus 8x squared plus 15x has to do what?
X times x minus 5 times x minus 3.
Okay. Yeah, it has to not equal 0, and yeah, we factor that, gives us x times x minus 3 times x minus 5. Absolutely correct. And we solve those to get the x tells us, whoops, go ahead. Perfect. X can't be 0, x can't be 3, x can't be 5. So what this is telling us is we can't be any smaller than negative 5. We can't go below negative 5. So our first interval is going to start at negative 5. Is it inclusive or not inclusive? In other words, round or square bracket?
Square.
Square, because it is or equal to negative 5. It includes the negative 5. That's going to go up to, what's our next stop going to be at? Our next restricted value is the 0. So that goes up to 0. So what do we put on the edge of the 0? A round bracket, because the 0 is excluded, right? Then a union. What do we start our next interval with? A curved bracket and 0 again. That goes up to 3, and of course that is curved. A union with curved 3, going up to 5, also curved. Are we done? Then we got union, curved 5 up to infinity. That's about as ugly of a domain as I would ever ask you to find. Any questions on that? Okay, I kind of jumped into reviewing and going over the material. We've got about 7-8 minutes left here. Are there any questions on the homework from last week or the quiz from last week? Okay, so make sure that that quiz is done before the end of the day tonight. End of the day today. That is due. Otherwise, for today, homework 10A covers the material for today. And remember, test 2 is coming up next week, Monday. So make sure you're getting ready for that. Any other questions? Okay, you guys have a great day. We'll see you tomorrow.